Okay, even more epic fractions for us to play with. I'm going to write this out bigger because we're going to need some space. We're going to need space because we have to construct a common denominator for this thing, and it's going to have 3 pieces to it, sad to say. This first fraction contains an x plus 2 in the denominator. This fraction doesn't have one, so we have to put one in. And we have to put it in the numerator as well. And this fraction also needs an x plus 2. Then, this middle fraction contains an x plus 1, so this fraction needs that. This last fraction needs that. And last fraction contains an x, so this fraction needs an x. And this fraction also needs an x. That's not where I would normally choose to put x's, but I don't have room to put them anywhere else, so I'll just have to grit my teeth and live with it for one more line. So, now these all have the same denominator. We're going to get one mega fraction here with the denominator x, x plus 1, x plus 2. All of these fractions contain those same 3 pieces. I put the order just in something that seemed logical to me. X plus nothing, x plus 1, x plus 2. You could have used the orders from any one of these guys. It doesn't matter as long as they all contain the same pieces. Now in the numerator we've got 3 times x times x again, 3x squared. And then we have 3 times 1 is 3 times x is 3x. Here, now this one's even more fun because this negative applies as well. So we have minus, this is 2x. I know that's not the order it's written in, but if you think of it as minus 2x, it's a little easier. Minus 2x times x makes minus 2x squared. And minus 2x times 2 makes minus 4x. And then, well, here we're multiplying by 1, so we can ignore that and get away with it. What matters is x times x is x squared. X times 1 is x. 2 times x is another 2x. Grand total of 3x from the outside and inside. And from the last, 2 times 1 is 2. So when we collect terms, we have 3x squareds. We lose 2 of them, so we're down to a single x squared. Then we get another one, so we're up to 2x squared. 3 x's, lose 4, so now we're at minus 1x. Then we get 3 back, so we're up to plus 2x. And then we have plus 2 over x, x plus 1, x plus 2. Can we do anything with that numerator? Say yes. We can do a tiny bit. We could take a 2 out of it if we wanted. Because it contains a common factor, you can pull that out and you get x squared plus x plus 1 over all the same stuff as before. That trinomial is not factorable. Go ahead and try if you want. It'll only take a few moments to conclude that you can't do it. There's no 2 numbers that add up to 1 and also multiply to 1. So here it is in factored form. And the non-permissible values, well, we'll get 1 from each of these pieces. We'll get x cannot equal 0. Easy enough. We get x plus 1 can't equal 0, which tells us that x must never be negative 1. So there's 2 non-permissible values. And finally we get x plus 2 can't be 0 either. Therefore, x cannot be negative 2. So 3 non-permissibles.